Okay, I'm going to make the video for Chapter 6, Overview of the Solar System, in two different parts. This is Part 1, Overview of the Solar System. So, how do we know so much about the solar system? Observational advances. The more technologically advanced we become, the more we learn about things, especially when it comes to space. Obviously, we used to use telescopes a lot, and we still do use telescopes a lot, but now we actually have the ability to travel to other places, at least nearby places like planets and moons and so forth. We use the idea of comparative planetology, which is basically that we compare every other planet to our planet. We use common things that we're very familiar with, like Earth days and Earth years, atmospheric comparisons. It's very similar to Earth, except for blah blah blah. So we always compare it to Earth because it's the planet we know the most about. So there's some basic planetary properties that we're aware of about our solar system. Sun contains about 99.9% of the mass of the entire solar system. So everything else in asteroids, comets, planets, inner kind of interstellar debris makes up that other 0.1%. We know how to measure distances to things using Kepler's third law, p squared equals a cubed. We can calculate the radius of nearby planets using a process called parallax, which is essentially just a geometry function. We calculate the mass of things using Newton's universal law of gravitation. That's the formula right here, right? If you know the mass of one object, g is constant. Mass of another object divided by the radius squared. We can calculate the rotation period of a planet, typically by observation, unless there's just something that inhibits that, right? Some gaseous planets are a little bit harder to calculate based on that. Density of planets, we can calculate the volume, and then divide that by the mass, and giving us the density of these different planets. So the overall layout of the solar system is broken into two major regions, the terrestrial and the Jovian planet regions. So it's oftentimes referred to as the inner and outer planets. So these are some properties in general about terrestrial properties, right? They tend to be small when compared to things like the Jovian planets or to the sun. They're small, they're rocky, they're dense. They all are close to the sun, hence the inner planet denotion. They have a solid surface. They have very little gas comparatively. Now, compared to what? Well, a gas planet or the sun. They have much slower rotation. Gas planets rotate faster. And they have weak magnetic fields, Earth being the only one that really doesn't have a weak magnetic field, and that's kind of an anomaly for terrestrial planets. So, Jovian properties are almost opposite to a terrestrial in many ways. They're gaseous. They don't, whether they have a solid surface or not is a question mark. It's something we're always still trying to figure out. They're relatively low density. They're far from the sun. They're really large volumes, so that's why their density tends to be lower. And they rotate fast. And they have really strong magnetic fields. Word Jovian means Jupiter-like. So we're going to get into some spacecraft exploration. The Mariner 10 was the first spacecraft to map Mercury. So I break spacecraft exploration into planets. So Mariner 10 mapped the same exact side of the surface 3 different times because celestial mechanics not as well known as it is today. So we only knew about 45% of the planet until the Messenger probe in 2008 was sent, and it mapped the rest of the planet. Venus is a hard planet to explore. This is something that Russia really tried to do. In the 60s, they started sending these probes known as the Venera probes. They sent more than 20 of them to the planet, but the atmosphere is harsh. So these probes crushed / melted. We're not really exactly sure which did the ultimate damage to the probe, but Probably a combination of the both. But the longest probe that Russia ever had to survive on Venus was 23 minutes. The U.S. has never sent a probe to the surface of Venus. We have sent the Magellan probe, which is over here, but it was an orbiter that just mapped through radar imaging, which basically the longer wavelength of radar light was able to penetrate the clouds and to map the surface topographically. Mars is kind of the planet that the United States has discovered, or I hate to say discovered, studied the most, right? So, starting in the 70s, we sent the Viking mission, which is the first surface probe, and it successfully collected geologic data. This led us to believe that Mars is kind of a rust color due to iron oxide in the soil, and this confirmed it. The Sojourner was the first mobile rover. It was launched in '97. Took a lot of pictures. It unfortunately got stuck at this little rock right here next to the platform, which is the Pathfinder, known as the Pathfinder. We sent the Spirit and Opportunity, which are larger rovers than the Sojourner, thereby less likely to get stuck, in 2003. They're dual rovers. They were built to last about 3 months. The Spirit still works, but Opportunity does not. Died a year ago. That may be backwards. I'm not sure. One of them is alive. One of them is dead. Another thing we sent was the Mars Climate Surveyor. It crashed into the surface. This probe was a huge embarrassment for NASA because it was a data calculation mistake. Global Surveyor was sent in '97. It's the most accurate map to date. It's what has given us the map that is actually on the globe in class. It's very, very accurate data. Do we have a planned mission to go to Mars right now? No, not really. But I don't work for NASA, so maybe they know something I don't know. Supposedly 2030, somewhere around there, they're going to send somebody there. Spacecraft exploration in the outer planets was a little more tricky just because of the celestial mechanics behind it. So the Pioneer series was launched to the outer planets just to kind of get the feel of how these probes were going to handle in deep space. They basically laid the path for the Voyager 1 and 2, which were a tandem pair launched in '77. They explored the outer reaches of the solar system. Both of them still alive today. Voyager 1 was slingshotted above the plane of the solar system, taking a closer look at Titan. Titan was of big interest in the late 70s and early 80s, and it still is of interest, but Voyager 1 gave us the first up-close pictures of it, revealing that it had an atmosphere, which we suspected it had an atmosphere, but it confirmed it. Voyager 2 still going to this day. Voyager 1 also still going. But Voyager 2 is still going along the plane of the ecliptic, which is, straight out past Neptune, past the into the Kuiper Belt now, and who knows? It's where it's at now is kind of shaky ground. We're not real sure how far it is, but it is believed to still be in the Kuiper Belt at this time. This is the information that was presented to or on the Voyager probes and the Pioneer series. Any probe that's going to go out in the long term is going to be sent out with this kind of information on it, which is pictograph information in case an alien species were to find it. And this disc is sounds of Earth, animal sounds, and hello in lots of different languages and so forth. Galileo was sent to Jupiter in the late '90s. Studied it for a long time. It was named Galileo, obviously, because Galileo studied Jupiter first to really discover the Great Red Spot, and also named the 4 Galilean moons. So the Galileo probe did extensive studies on those moons as well. It was eventually crashed into the planet as it was dying. This is a designed, part of the mission. Cassini was launched in '97. Cassini is the most advanced probe we've sent before, or since, or I'd have to say, maybe even more advanced than the New Horizons to Pluto. Cameras and so forth on Cassini are just amazing. It's had the Huygens probe attached to it, and it's just like another little lander probe that was dropped onto Titan and gave us atmospheric readings about Titan and also visual images of the moon of Saturn. Cassini's done the most extensive study of the rings. It continues to study to this day. New Horizons is the one that's in the news. Currently, anyway, year 2015. It was launched in 2006. It was the fastest probe ever launched. It arrived at Pluto in 9 years, which is quite the accomplishment for how far away it is. This is the probe itself. First probe to explore Pluto and its moons. This is an up-close picture of Pluto from the New Horizons probe. This is Pluto's largest moon, Charon, also from the New Horizons data. So this is very new data at the time. Again, this video is being made in 2015. Gravitational slingshots are the idea that we use gravity to speed up or slow down spacecrafts. It is collectively known as celestial mechanics. And celestial mechanics is the idea that you can use planets and other bodies in space, like asteroids and stuff, to speed up or slow down. So if you pass behind a planet, it speeds up. You steal a little bit of the gravitational energy of the planet. If you pass in front of it, it kind of creates a little bit of gravitational drag and it slows down. I showed a video on this in class, and if you need further information on it, just Google it, and there's tons of stuff on gravitational slingshots and celestial mechanics. Very cool stuff. Multiple different types of asteroids, and we'll kind of define this in a minute, and I'll come back to this image. Most asteroids reside within the asteroid belt. It's a highly dense region between Mars and Jupiter. It contains most of our solar system's asteroids. Origin of them is a little bit of a question mark. We're not exactly sure where these things came from, but there are two different major theories. The major theories are that they're fragments of a ripped apart planet, or it's leftover crap from the formation that never accreted to form a planet. So it's probably the latter. We're not 100%, but it's probably the latter. Three main types of asteroids, classification-wise. You have a C-type, which is carbonaceous, which means it's mostly carbon. They're dark. They're not very reflective. These are the most dangerous type for impacts onto our planet because they're so hard for us to identify where they're at. S-types are silicates, which are rocky ones. Silicate is obviously a type of rock, and it's very common on planet Earth, so we know that we've been hit by lots of silicate asteroids before. Third type are M-types. Their M-type stands for metal, right? And they're mostly iron and nickel. Now, obviously, compositionally, these things probably have everything in them, but we say they're M-type if it has mostly metal, or S-type if it's mostly silicates. A couple examples of some asteroids. Now, Earth has some asteroids that cross its orbit. These asteroids are identified as Apollo asteroids. There's a lot of them, 2,600 or so, and that's as of 2004. So it's probably more of them been identified since, but it's around that number. About 600 of them are classified as potentially hazardous, which means they're 10 kilometers or larger in size. Amor asteroids are asteroids that are Mars crossing. Now, if you look back to this diagram, and I'll show it, the Apollo asteroids, you got to find Earth's orbit here. Right? Apollo asteroids is this red line here. So they will cross Earth's orbit. Now, Apollo asteroids will also have the potential to cross Mars's orbit, so they could impact into Mars as well. So now just because they do cross the orbit doesn't mean that they will impact. It just means that they have a likelihood to. So if the planet is here, for example, and the asteroid is here, then obviously it doesn't hit. More asteroids are the opposite, or not opposite. They are Mars crossing. Now, they will only cross Mars's orbit and not Earth's orbit. So they hang out in the asteroid belt, and then eventually they will kind of get perturbed to be pushed into here or so, right? And then they'll hang out here for a while and come back in. Most of their trajectories are well known. So, like I was saying earlier, it's mainly or more likely that the asteroid belt is just leftover stuff that Jupiter never allowed to accrete to form a planet. Jupiter's extreme gravity keeps like tugging them to and fro, and the asteroids are not allowed to basically get together. Another type of asteroid is the Trojan asteroid. And Trojan asteroids are asteroids that are caught in a tug of war between Jupiter and the Sun. So, in what's known as the Lagrangian points, which is right up here. So, there are groups of asteroids that are east or west of Jupiter, and they are within Jupiter's orbit. Jupiter kind of pushes them and pulls them along, and the reason they don't go crashing into Jupiter is because they're also accelerated by the Sun. So, it's kind of caught in this gravitational tug of war. The Chicxulub asteroid is the Dino Killer, and the Dino Killer happened about 65 million years ago. And it is believed to hit in Yucatan Peninsula of Mexico. We have geologic evidence of this now. This is where the crater is in current-day Mexico, and hit partially on land and partially on water. We're not sure if that was all water at that time or partial land, so the geology of that is kind of questionable. The reason we know this is iridium. There's a layer of iridium that, well, first of all, we obviously have the impact crater. But the second reason we know that is that there is a layer of iridium geologically spread throughout the planet at about 65 million years ago. Well, iridium is a rare metal that we don't normally see. And it is very common in asteroids, though. Hey, I like that. Now, this little section is about meteoroids. Now, this lovely young man here is standing in front of a meteoroid that is the largest meteoroid to ever hit the planet. But because it has hit the planet, it is no longer a meteoroid. So, the classification of meteors, meteoroids, and meteorites is really what you need to know. They're essentially small asteroids. If it's floating around in space, it is what's known as a meteoroid, just like an asteroid. If it happens to enter the Earth's atmosphere and burn up, it is known as a meteor. And if it actually makes it through and impacts the body, right, then it is a meteorite. So the ones that lovely young man was standing next to were meteorites. So there's another one right there, meteorite. So there again, that lovely fellow. Alright, that's part 1 of the video. Part 2 will cover comets, Kuiper Belt, Pluto, and the creation of the solar system.